And we're looking at trains that can travel for up to 100 kilometres in some cases and recharge in only 10 minutes.
Especially public service routes where these aircraft are essentially used like buses and they're lifelines for people. One day, that fuel that they currently use just won't be available anymore.
So you've got blue hydrogen and green hydrogen and all the colors of the rainbow. Probably now there's also gold hydrogen, if Power Rangers are to be believed.
Hi, and welcome to Emissions Impossible. I'm Kim McAllister.
I'm David Leipziger.
Everybody get up.
Now, I am a broadcast journalist with a bit of a sore voice today, but David, you work for Innovate UK, and that must be the coolest job.
It is a very exciting job, and no more so than now because I'm under a blanket in my guest room recording this exciting podcast with you.
You're so professional. I love that you suggested the blanket before I even had to ask.
Yeah, well, I'm nothing if not innovative. Hopefully it sounds okay.
It sounds great. So in this episode, we're going to discuss transport and its role in the emissions mix. Can you give us a bit of an overview? How much does it contribute to our greenhouse gas production?
So the transport sector in the UK at the latest count was something like 27% of our total emissions. And depending on how you look at it, that could be a lot or a little. But the most important thing I think to recognize is that contrary to most other sectors, transport emissions in the UK have not gone down in the past 30 years. So it's a critical sector to address because it's really lagging behind.
Yeah, and it's not something we can really avoid, is it? We need to get places.
Yeah, I famously describe transport as being a fabricated sector because people need to do it, but they don't do it for the joy of it necessarily. It's a function of where people live and where they work, and people have to move around to get things. So it's just a byproduct of the other things that happen in their lives.
It's just life, isn't it? So we're looking at lots of different ways of making less of an impact on our planet with our travel. How well placed are we in the UK in relation to the rest of the world for that switch?
I think the UK is really excellently placed, and there are a couple of factors that lead into that observation. First, because we are one of the few countries in the world that has actually made a public and political commitment to getting to net zero. And second, because of our own intrinsic skills and expertises. So we are a long time leader in high value manufacturing and in various transportation sectors from maritime to aviation. And we also have a lot of skills that are emerging that are really useful in net zero services. So in renewables, in computer programming and quantum computing, and we have some of the world's highest quality educational institutions that are driving that innovation too.
You're painting a good picture. I'm liking this. So in the course of this podcast, we're gonna go on a bit of a journey. We are talking about transport with planes, trains, and automobiles. So we've asked some Innovate UK funded companies to tell us about their innovations, and we're going to start with the biggest challenge, which is aviation. So Jenny Kavanagh and Paul Hudson from Cranfield Aerospace have told me that they're working on an electric hydrogen powered plane.
So we're starting at in the smaller aircraft. We're starting with a 9-seat Britten Norman Islander. So that's an aircraft that's been manufactured in the UK for a number of decades. It's used all around the world. It's typically used essentially as a bus in those geographies where communities find it difficult to get around by road transport. So between islands and between the mainland and islands. So it's a vital transport requirement. And what we're going to do with that is we're going to introduce a hydrogen fuel cell system into the aircraft to give it completely emissions-free flight. So what I mean by that is you think of a typical aeroplane. In this case, it's got two propellers, one on each wing, with a conventional engine turning those propellers. What we will do is we'll remove those engines and we'll replace them with electric motors. So those motors will then turn the propellers. Behind those electric motors, we'll package in the nacelles, which is where the engines would normally sit. We'll package hydrogen fuel cells. They produce the electricity for the electric motor to turn the propellers. And elsewhere in the aeroplane, we'll store gaseous hydrogen, which we'll supply into the fuel cells to give the fuel cells the fuel they need to produce green electricity. So it's a completely end-to-end green process. There are no emissions other than water vapor, and that enables the aircraft to operate the way it would normally operate.
And if I could add to it, just to emphasize why what we're doing is so important. Okay, because there were people out there thinking, how is a 9-seat aircraft going to solve the problem for aviation, right? And I guess it's not. It's not going to solve the entire problem. But one of the things, well, there are two key aspects really to developing the technology. One is getting the technology to work, which is what the likes of, on the larger aircraft, that's what the likes of Airbus and stuff are working on really big fuel cell systems and the hydrogen combustion systems. But the other side of it, and on the small aircraft, obviously, that's what we're doing as well. The other side of it is the certification. So if you don't work in aerospace, you probably don't appreciate it. But everything that goes on an aircraft has to go through rigorous safety analysis, testing, to prove that it is safe for obvious reasons. And because this technology is different, it behaves differently to normal jet fuel, and the engines, in inverted commas, are not gas turbines, they're fuel cells and electric motors. There are currently no certification standards from the authorities to work to. So by getting a small aircraft into service, you start solving those problems for the rest of the industry. Because once you've done it, you can then build on that. You have a precedent. It's like, law. Once you've done it once, you have a precedent you can build on. Getting rid of that inertia in the system and creating that momentum is incredibly important. And that's why even the small aircraft, it's so important we get it into service and not just have a technology demonstrator that proves physics.
Yeah. So how soon can we get this off the ground then?
Project Fresson is it will be delivering a flight demonstrator Q1 2023. So January to March 2023. That will be a demonstrator of the technology, and it will be the first step on the certification path because it will have to have done technology will have to have undergone certain testing and things to make it safe for a demonstration flight. Following on from that, though, in terms of passenger service, we are aiming by the beginning of 2025 to have this aircraft in service with people on it paying for their fares. And that will kickstart the whole thing, which is incredibly exciting.
We've carefully structured the project to get there as soon as possible. And what I mean by that is, I said earlier that we started off with the smaller aircraft, so we looked very carefully at the market and chose what's called sub-regional aircraft, the sub-regional segment, which is typically 9 to 19 seats, just because the maturity of this technology, hydrogen fuel cells in aircraft, is not yet there for the larger aeroplanes, but it's mature enough to get the smaller aeroplanes flying. But we also were very careful within that segment to choose a specific aeroplane where its use means it tends to be flown for short hops. So the Islander aircraft can fly for 2 to 3 hours, but typically, because of the way it's used between islands, between the mainland of islands, 85% plus of its operation is for 60-minute flights or less. So by only needing to give it a short range, we were making the technical challenge of getting the correct amount of fuel in to power the fuel cells. That was reduced. So we've tried to very carefully at all steps choose the simplest route to get this done quickly, because as Jenny says, getting that first certification step benefits the whole of the aerospace industry because you've then proven that you can get these technologies working. So you want to find the simplest version of the technology to prove it on, and that's why we've chosen the Islander to get that first step, and that's why it'll be quick.
So will it be used in the islands off Scotland, off England? Is it a UK island plane that we're going to be seeing flying with hydrogen?
Certainly hope so. Yeah, we're talking to the airlines around the UK about that because, they, especially public service routes where these aircraft are essentially used like buses and they're lifelines for people. And one day that fuel that they currently use just won't be available anymore. And especially with the great work that's been happening up in the Orkneys and Shetlands regarding renewable fuels, the hydrogen the hydrogen economy that they're building up there, and the work with the smart islands down in the Scilly Isles, the Isles of Scilly. they have just lend themselves beautifully to this technology, and there's absolutely no reason why this journey can't start in the UK.
So that was Jenny Kavanagh and Paul Hutton from Cranfield Aerospace. Sounds amazing, a really exciting project in Scotland, but how long do you think it's going to take the aviation industry to adapt?
It really depends who you ask, and I'll have colleagues at Innovate who might have different opinions, and admittedly who might be more aviation experts than I. But we are starting to see some seeds of change now, particularly in terms of travel behavior that's been precipitated by COVID. So that may have catalyzed the journey. But I really think it's going to take 20 years to actually change on a technological infrastructural level how aviation functions.
It's these long journeys, you know. You can be in a plane for 12 hours these days. I mean, they're just, I can't imagine how much hydrogen that would require, or how you would do that without standard fuel.
Yeah. And part of the big issue with hydrogen in particular is weight,
Mm.
because there are big weight differences between hydrogen and traditional fuels. So we need to spur some more innovation to figure out how we can carry sufficient hydrogen or another workaround.
Another fuel source. Excellent. Well, I mean, one mode of transport that's adapting rapidly is the automobile sector, because electric cars are getting more popular by the day. I'm a big fan. Our family car is now an electric car, and I've got a little runaround, which is a hybrid. I'm aiming for an electric car with that as well. But hydrogen might have a role to play here too. So here's Will Knock from Bramble Energy to tell us about the work that he's doing with fuel cells.
So a fuel cell is a device that converts chemical energy from a fuel into electrical energy. It's similar to a battery, so there's no combustion. The conversion from chemical energy to electrical energy is direct. I suppose the differences between a fuel cell and a battery would be that obviously a battery can charge and discharge, whereas a fuel cell would use up the fuel, and it can run for as long as there's fuel being provided to the fuel cell.
So what is it made of?
I suppose the interesting science happens across a membrane, and each membrane is enclosed by plates on either side, and the membrane itself will act as a barrier to hydrogen, which is injected on one side of the membrane, and oxygen, which is reactant on the other side. The membrane contains a catalyst, and that essentially disassociates or separates the hydrogen into separate ions, which can then pass through the membrane. That creates a differential charge, and the electrons are split from the hydrogen, and they can flow around the membrane, and that creates the electrical current, and that's then how you can power electrical appliances. There's a platinum catalyst used, and then bipolar plates are the plates either side of the membrane. They're typically used, or they're typically made from stainless steel or graphite, and our technology is actually using a printed circuit board, so it's slightly different to conventional fuel cells.
Wow, thanks for the science lesson. That was interesting. Until I spoke to you, a fuel cell was something that Power Rangers used. So I feel a bit more informed. So how do we use this particular technology to replace carbon technology?
Sure. So the fuel which we're looking at using, so we're using hydrogen, so that has no carbon in its form. So when it's converted into electrical energy, it's reacting with oxygen to make water, so there's no carbon emissions from that reaction. The way that hydrogen is then manufactured or produced, so that can be manufactured from renewable electricity with electrolysis, which is essentially the reverse of a fuel cell, or you can also make hydrogen from natural gas through methane reformation. That does produce CO2, so there's a whole, I suppose, effort going to try and capture that CO2 made from that technology. But those are I suppose the two main approaches of producing hydrogen which are being looked at.
And the only byproduct is water, so that's also good.
Exactly. Yeah. So it's a pretty neat solution.
And how do we use a fuel cell when we're not a Power Ranger? What would we put it in?
Yeah, I have to think of some uses that Power Rangers can use fuel cells for, but you'd use it for anywhere where you need electricity. So we're looking at the moment for off-grid applications. So the transport sector has a need for decarbonisation. Currently, the UK's transport sector is the largest sector in terms of emissions. It's about a third of the UK's emissions. So we need to really decarbonise transport. And so by electrifying vehicles, we could do that either with batteries or with fuel cells, and they can kind of work together. So we've obviously seen lots of battery electric vehicles in passenger cars over the last decade. That's great to see. We need lots of electric cars. Fuel cells can also be used in electric cars, but we also see growing applications in the heavier duty transport sectors, so buses and trucks, like commercial vehicles, so vans as well.
Can you describe a fuel cell to me? Because I am picturing a battery. Am I off grid?
Yeah, so a battery is made up of cells. So I suppose they look a bit like those AA Duracell batteries, and they can be put together. So whereas a fuel cell itself, we make our fuel cells with different plates, so we can stack those together. So it doesn't necessarily need to be a cuboid, and we are looking at different form factors and shapes, but you would stack up a series of these cells together to make a fuel cell stack, and we can make that into the same form factor as a battery pack, for example. We're also looking at being a bit more flexible in how we design that so that can fit within the vehicle.
Cool. So for a car, so I'm thinking if you filled a fuel tank, you'd maybe get 300 miles out of a car, an average car. Would a fuel cell need more space, less space? How would it compare?
So the fuel cell itself, once we're making them at scale, will be smaller and lighter weight than an engine. The hydrogen tanks, though, which you also need to power the fuel cell, at the moment they're heavier and take up more volume. So the combined powertrain and the energy storage is slightly more challenging to package in cars. We're looking at how we can be a bit more clever around packaging the fuel cell, and there's been lots of developments in the electrical drivetrain, so the motors and wheels, and we can look at how we can package that in a more, I suppose, a different approach, rather than taking a vehicle that's been designed around an engine and that powertrain. We can sort of design it from a completely different angle.
Something new. Well, this is something that we touched on in the shipping episode, was retrofitting versus a new design. And I guess there's a place for both as we transition to a net zero economy. So I'm interested in how that will look. And then there's obviously some conversation around batteries for electric vehicles. They can't be recycled, for example. They use cobalt and lithium, and there's some discussion about where they come from and the mines that they come from. What are the sort of discussions around the fuel cells?
We're trying to design our fuel cells to be as recyclable as possible. And there is a lot of effort within the electronics industry to recycle printed circuit boards. So that's something which we'd be looking to incorporate into our design. So we're designing for the operation of the fuel cell, but also for the end life and recovery of materials from the fuel cell.
Great. So it sounds like a slightly more environmental solution than a battery so far?
Yes, well, it should be easier in theory to recycle.
Good. So we're talking in theory. What stage are you at in your research, and what support have you had from Innovate UK?
At the moment, we have developed our fuel cells, and we've shown that they can work at a smaller scale. And we've just launched last month a demonstrator vehicle where we had our fuel cell integrated that into a van, and that was supported by Innovate UK, and that was an Innovate UK funded project, which we're also continuing in the next phase, and we're working with Marla Powertrain to do that. We're also looking at different applications. So another Innovate UK Department for Transport funded projects looking at applying our fuel cells into marine applications as well. So we're looking at how fuel cell can be marinized and integrated into a boat to reduce emissions in that sector.
Wow, marinized. That's a good word. I like that. So how do you see this being adopted? Because this is another thing that we need to consider, don't we, about how we work with the market as it is and how we want it to be. Do you think it will be a partner for a battery to begin with and then maybe stand alone?
Yes, so that's exactly what we've been doing with the van. We've been taking an electric vehicle base and putting our fuel cell onto that. So that fuel cell plus the hydrogen tank essentially generates electricity to recharge the battery, but that allows the vehicle to travel for a longer distance. And in our case, we can refuel the tank in a couple of minutes. So that cuts the waiting time to recharge. And that makes it, I suppose, a bit more like a diesel or petrol vehicle, but without the emissions, and runs silently just like an electric vehicle.
Sounds like the best of both worlds. I'm quite intrigued. When can I buy this car, please? When are we going to have this on the market?
Yeah, we're working to as fast as we can to prove that our fuel cells can work and can live up to the requirements for long operations and meet the automotive standards. So, yeah, a couple of years hopefully.
Excellent.
That was Will Knock from Bramble Energy, and I like that he laughed when I referenced Power Rangers. Were you a Power Rangers fan, David?
I was, and I'm American, so I'm even more directly implicated. So yeah, I know all about it, and happy to discuss your favorite color if you'd like.
Well, they're on like the fifth or sixth crowd of Power Rangers now. My son's 6 and he's obsessed with them. He likes the gold Power Ranger. It's called Levi. I don't know if you're still up on this.
Yeah, I don't know if it's showing my age in the right or wrong direction to say that in my day we didn't have a gold Power Ranger, so
Mm.
I can't comment. I don't know who it is.
They use a lot of fuel cells in Power Rangers, but I reckon what they're using and what we're talking about here might be slightly different things.
Maybe that was the impetus for the hydrogen fuel cell.
You
Someone
never
saw it on Power
know.
Rangers.
You never know where inspiration might strike. Do you think fuel cell technology is the future, though?
I do, in the sense that I think it's going to become mainstream very, very quickly. But I also, as an urban planner, advocate strongly for non-motorized transport. So I am also keen to see developments in areas of urban transport that focus on cycling and walking and trying to reduce the need for cars in general. So I
Mm.
think there's going to be a common trend of the standardization of things like fuel cells or other electric vehicles alongside a push for, particularly in urban centers, not needing cars as much in general.
I know. I would love to not need a car in Edinburgh city centre.
A lot of cities the world over really are realizing the importance of prioritizing people over vehicles and particularly over cars.
Hmm.
And I think that sea change is starting to hit the UK as well. And we're going to hopefully see policy developments that make that easier and that can coincide with the type of technological solutions that Innovate supports.
Yeah. Well, I mean, we couldn't go on a journey without stopping by the train station, right? And it might be one of the most green forms of travel, but electrification is still pretty expensive. So Alice Gillman from Viva Rail has pulled in to tell me about their innovation.
Trains are already the greenest form of transport, as you know. We account for a growing number of passenger miles, which is good, and we are an enabler to get people out of cars and freight off of the roads. So that's setting the kind of scene. What we've got in the country at the moment is some great quality new electric trains coming through, a programme of electrification. Now, electrification is the gold standard. It's the best way. You get clean, green, they're reliable. However, it's hugely expensive. So we're still running diesel trains across the UK. And in some cases, those trains are running under the wires, which means they're using electrified track and then having to continue on their diesel engines afterwards. So we're still getting those emissions. And we're an industry that's moving really, really quickly to decarbonise.
Yeah, and also playing your part in a bigger journey, if you'll forgive the pun. You know, people can then do more active travel using trains to join up those bits that they can't quite manage, on foot or on bike, right?
Well, exactly that. We call it mobility as a service. So, what you're looking at, especially if you think of somewhere just outside a park and ride, something just outside the city centre, you can take your car there because, yes, you still do need to use your car for some parts of it. Hop on into your shuttle into the city centre. And this is where our technology is particularly useful because it's based on batteries. Now, batteries themselves, battery trains aren't new. They've been around for over 100 years. But what's always stopped their implementation before is that they take a long time to charge up. Not anymore. We've developed new generation batteries that can accept a really high rate of power going through them in a very short space of time. So these batteries now combine range with rate of recharge. And we're looking at trains that can travel for up to 100 kilometres in some cases and recharge in only 10 minutes. So it is a bit of a game changer when you look at what's needed in service patterns and how you can get the diesels off and replace them with something that's emission free without having to pay for all that overhead line electrification.
Yeah, so it sounds like the best of all worlds. How quickly are we going to see this happening on our trains?
Well. We launched our first battery train in 2018. that was a train, or really, it was a demonstration train. We just really wanted to test out that it could do exactly what we thought it could do. And in terms of the battery performance, it certainly did. It was very, very encouraging results. So we thought, well, we'll carry on. We'll carry on with the development of the batteries, but it's got to be this recharging that we crack. So with the help of a grant from Innovate UK, we've developed a system called Fast Charge. Now, Fast Charge, like all good ideas, is really actually quite simple. It's a trackside battery bank. So you're talking, a big shipping container stuffed full of batteries. We're trying to use second use batteries as well, so that their life is extended. It's connected through a safety system and through to conductor rails, which are short sections of rail. So if you imagine, like, you get on the underground, it's short sections of those kind of a third and fourth rail. They aren't live until the train pulls into place. And then there's an electronic handshake that takes place between the train and the power storage banks. At that point, the tracks are allowed to become live, and we whop a load of power straight back into the train. Train's up to 100%. Actually, it's not up to 100%, because you don't charge them up to 100, because you also want to recapture the regenerative energy as you're braking, going through the journey. But train's ready to go. Off it goes, and the power banks trickle charge themselves back up again. They can also charge using renewables, so solar, wind. This is a wider picture than just outside of rail. But if you think about it, you've got a station car park, power storage banks, and an emission-free train. Great, so you've replaced a diesel. But you've also got a growing need for electric vehicle charging points. Instead of having to do individual ones, we've developed really a concept where you can use our central power storage bank to charge the EV charging points. So you've created yourself a whole, and it's all part of that mobility as a service thing. Yes, recognise cars are needed. Make it easy for people to make the change to rail.
Yeah, that sounds great. So you get your electric car, you can charge it while it's parked,
Yes.
while you've taken your train into town to do what you need to do, come back out, get home, and not a single emission has been emitted. I like this.
Pretty much, yeah. So it's really, when we started looking at battery technology, okay, so it can do this, right? That's interesting. But if you did that, and there you keep going on, and batteries are so blooming flexible. They really, really are. We're looking at other types of train. Now, we work on what we call our Class 230 platform, which is stock that we already own. Interestingly, as well as part of our whole green agenda as a company, they are trains that were retired early from the district line. So rather than going to scrap, we bought them, and we've been, using those. We've sold fleets to West Midlands Railway, Transport for Wales, South Western Railway, and we've also exported battery trains to the United States.
Wow.
So we're building that export market as well.
So that was Alice Gillman from Viva Rail. It's turned out to be a pretty dynamic episode there, wouldn't you say?
Absolutely. But everyone can get excited about transport, don't you think?
Well, we all use it, right? So why not? I love it when someone's so passionate about their job and their innovation as well. I find that really inspiring.
Yeah, that's part of the joy of working at a place like Innovate, is people care a lot and know a lot.
Yeah, I love it when we can geek out and stuff like that. So given all the stuff that we've heard today, are you feeling positive about the future of the transport sector?
I am. Also, it's partly my job to be positive about it, partly a coping mechanism to see the glass half full. But I do think that we're making a lot of progress, and you see things moving in the right direction. The electricity mix or the fuel mix for electricity in the UK is all on the right trend. So now nearly half of electricity is generated by not fossil fuels. And as that continues, it's just going to make electrification or electric vehicles less polluting. And with hydrogen, we're investing a lot in the infrastructure and manufacture. We'll find out soon enough what type of government resource is going to go into that. But hydrogen is a tricky one also, because you can make it in lots of different ways. So you've got blue hydrogen and green hydrogen and all the colors of the rainbow. Probably now there's also gold hydrogen, if Power Rangers are to be believed. But you can make it through lots of different processes, and those pollute or produce emissions to different degrees. So there is a more green and a less green path to hydrogen. But I do think that we're recognizing that those are the technologies that are going to really sustain a net zero transport future. And if I have anything to say about it, we'll be supporting that as much as possible with Innovate.
Awesome. Yeah, you guys are doing great work. It's really cool to hear about all the companies that you're supporting, and makes me sleep a little easier to know that all these innovations are happening and that we're finding alternatives, because, you know, then we're one step closer to making emissions impossible.
Emissions Impossible is a Connect production for UK Research and Innovation. If you like what you hear, please hit subscribe.